So now I'd like to go over slide 6 in the PowerPoint, which deals with soluble salts and insoluble salts. So there are some things like this piece of chalk that they don't dissolve very well in water. So I'll take my deionized water. Let's make sure it's deionized. Yep. Okay. And I'm going to take this piece of chalk, we're going to drop it in there, and I'm going to swirl it around. It doesn't do a very good job of dissolving. We come back here tomorrow and that piece of chalk is probably still going to be in there. Now a little bit dissolves. I don't know if enough dissolves for me to pick this up. Let's see. No, not very much. So while a little bit dissolves, there's not enough that's dissolving for me to be able to pick this up with this particular tester that I have. Well, of course, sodium chloride, that dissolves really well. Just give that a little swirl and we can probably already hear it. Yep. So here I've differentiated between a salt that does dissolve and a salt that does not dissolve. And there's just a set of rules that we use. And this set of rules is on the slide 6 of your PowerPoint. It helps us to predict whether a salt is going to dissolve or not. And I'll just go through these rules with you. All alkali metal salts are soluble. What does that mean? Well, that means if I have sodium as a cation, anything else as an anion. I could have sodium nitrate, I could have sodium sulfate, I could have sodium perchlorate. These are all going to dissolve. Why? Because sodium is an alkali metal, and an alkali metal compound, an alkali metal ionic compound, is going to dissolve in water. That's just a rule that you really ought to remember. The same is true for any other alkali metal cation. So this could be potassium sulfate, that's going to dissolve in water. Lithium sulfate, rubidium sulfate. Any first column, anytime you see a first column element in an ionic compound, you know that thing is going to dissolve in water. It's also true that ammonium compounds, NH4, the ammonium ion, if you see the ammonium ion in a particular compound, then you know that particular compound is going to dissolve in water, and it's going to form ions. So it's going to conduct electricity. As you can probably tell, as we move through this chapter, it's going to be a good idea to get familiar with your polyatomic ions if you haven't already done so. You're going to be seeing them a lot. So that's the first rule. You see an alkali metal, or if you see the ammonium ion in an ionic compound, the substance is going to dissolve. The second rule is that if you see nitrate, NO3, it's got a negative charge. So if you see the nitrate anion in a compound, it's going to dissolve. These first two rules that you see on page slide 6 of the PowerPoint, you really want to know these two. Those two need to be, just part of your vocabulary in a sense. So anyways, with nitrate, any nitrate salt, so let's see, calcium nitrate. It's got nitrate, it's going to dissolve. Sodium nitrate, well, of course that's going to dissolve. It's got two things in it that tells us it's going to dissolve. It's got an alkali metal cation, and it's got the nitrate ion. So with these two rules, alkali metals, actually it's three, all alkali metal compounds dissolve, all ammonium compounds dissolve, ionic compounds, and all nitrate compounds are going to dissolve. They're going to be soluble in water, kind of like what we see here with the salt water. Let's see if enough of this is dissolved yet. I just want to see, just for the heck of it. No, still nothing. Okay, let's go to the third rule. The third rule says that halides, the halides chloride, bromide, and iodide are soluble, but there are some exceptions. So if I see, for example, calcium chloride, there's a good chance that that is going to dissolve because of this rule that chloride, bromide, and iodide salts are soluble. But I need to check through the exceptions. And the exceptions are silver chloride. This does not dissolve. This is more like the chalk in water. Another exception is mercury 1 fluoride. This does not dissolve in water. And the other one is lead 2. Lead 2 chloride. So bromides, iodides, and chlorides of silver, mercury 1, and lead 2, those do not dissolve in water. So there's some exception to this rule that chlorides, bromides, and iodides, we should say they tend to be soluble. They tend to be like salt water, but there are some exceptions that you need to be aware of. So you ought to be referring to PowerPoint slide number 6 quite a bit when you're thinking about whether salts dissolve or not. The fourth rule deals with the fluoride ion. And the fluoride ion is also generally soluble with some exceptions. So the fluoride ion is soluble, but there are some exceptions, and those happen to be magnesium fluoride, that tends not to dissolve. Calcium fluoride doesn't dissolve. Strontium fluoride, barium fluoride, and lead 2 fluoride, these do not dissolve. Any other ionic compound that has fluoride attached to it, you can assume that that's going to dissolve in water. The last rule in the soluble section deals with sulfates. Sulfates tend to be soluble. So let's see. Sulfate, SO4 2-. So your sulfate salts, well, of course, sodium sulfate is going to be soluble. I mean, it's got the sodium ion. It's got a group 1 metal, so of course that's going to dissolve. But again, there are some exceptions to this sulfate rule, and those exceptions are calcium sulfate, strontium sulfate, barium sulfate, and I think it's lead 2 sulfate. Yep, lead 2 sulfate. These do not dissolve while other sulfate salts do. And interestingly enough, chalk is often made of calcium sulfate, sometimes calcium carbonate, sometimes a mixture. Oh, maybe a little bit starting to dissolve, just a bit. And that does happen. You should recognize this, that these soluble salts do dissolve a little bit, but not nearly to the extent of sodium chloride or the soluble salts. Okay, now there's some rules with the insoluble salts. If you see these particular anions, the salt's going to be insoluble, like chalk, unless, of course, it's attached to an alkali metal ion or ammonium ion, because those are always going to dissolve. So let's see, our insoluble salts, carbonate. Carbonates tend not to dissolve. Calcium carbonates found in chalk tends not to dissolve. Calcium carbonates found in seashells. Of course, the organisms that make the seashells, they don't want those to dissolve. So carbonates tend to be insoluble. Phosphate. Phosphate salts tend to be insoluble. When I say tend, we remember that this thing is not going to dissolve unless it's attached to ammonium or a alkali metal cation. Sulfide, oxides, and hydroxide. These salts, these anions, if they're contained in a salt, will probably not dissolve. Again, we remember the exceptions with the alkali metals and the ammonium ion. So let's go ahead and have you do the problem on PowerPoint slide number 6. Why don't you go ahead and answer those questions, asking which of those following salts that are listed will dissolve in water, and use the rules above to do that. And then after a pause, we'll come back and I'll give you the answers. All right, I've got the compounds written on the board, and we'll go through and see which of these are soluble, which dissolve like salt, and which of them are insoluble like chalk. If I look at this one, I see an alkali metal cation, the lithium ion, so I know that dissolves. That's the first rule. Calcium hydroxide. I see the hydroxide, and hydroxides tend to be insoluble if you look down in the insoluble salts, and calcium is not an exception. The only exception to the insoluble salts are the alkali metal cations. So this does not dissolve in water. Lead 2 sulfate. Better check through the rules on this one. Salts of sulfate are soluble. That leads me to believe that this might be soluble, but you'll notice that lead 2 is an exception, so lead 2 sulfate does not dissolve in water. Silver fluoride. Let's look through the rules. Salts of fluoride are soluble. This could be a soluble salt, and I do not see on fluoride, I do not see silver as an exception, so we would expect silver fluoride to dissolve in water. If we go to silver chloride, I know that most chlorides dissolve in water, but there are some exceptions, and silver happens to be an exception to that rule. So silver chloride does not dissolve in water. Calcium carbonate. Carbonates, these are one of these anions that tend to not dissolve in water, and the only thing that would be an exception would be the alkali metals or ammonium, and we see calcium paired with it, so this is going to be an insoluble salt, which is a good thing for seashells. And then finally, we see here sodium carbonate. Of course, carbonates tend to be insoluble, but it's paired with an alkali metal cation, and those are always soluble, so sodium carbonate is a soluble salt.